Alright guys, let's look at lesson 9, which is molecule polarity. So we first have to talk about types of electron pairs. And we've talked about these a little bit in class yesterday. So we have bonding pairs, which are the pairs of electrons that form bonds. And then we have lone pairs. Those are what we're going to call those non-bonding electrons. So let's look at this molecule of NH3, which is ammonia. Okay, when we draw our Lewis dot diagram, we have the bonding pair of electrons, which is going to connect the nitrogen to the hydrogen, and the lone pair or not bonding electrons is going to be these two electrons down here at the bottom of nitrogen that are not involved in the bonding process. So that's going to lead us to two things, which is going to determine the molecular polarity. The molecular polarity, or the polarity of the molecule, depends on two things: the bond polarity and the shape of the molecule. So is it symmetrical or non-symmetrical? And the shape that these molecules have is caused by VSEPR. So that is the valence shell electron pair repulsion. So that means that the valence electrons are arranged as far from one another as possible to minimize the repulsion between them. So what does that mean? That means that if a molecule is polar, it contains polar bonds and is asymmetrical. That means it's not symmetrical. And if there are lone pairs on the central atom, then the molecule is automatically going to be polar. A nonpolar molecule is a molecule that contains nonpolar bonds and is symmetrical. So let's look at the shapes of polar molecules. These are molecules that are going to have an unequal sharing of electrons. So let's look at what these shapes are. First is going to be linear, and it has to be asymmetrical, meaning that the element on the left is different than the element on the right. So carbon in this case is going to be partially positive because oxygen is more negative, more electronegative, so it's going to pull the electrons away from carbon. So this is going to be a linear molecule. See, as you can look on either side of this line, if we were to fold it in half, they're not the same. And these elements are going to be 180 degrees away from each other. And next one is bent. This is when a lone pair of electrons, this is when you have an atom that has two bonding pairs of electrons and two non-bonding pairs of electrons on the central atom. So in this case, we're looking at the molecule of water. We've talked about this in class. So we're going to have a partially negative oxygen at the top, two partially positive hydrogens on either side on the bottom. The oxygen is going to take all of the electrons, or more of the electron density, away from the hydrogens, making each hydrogen partially positive and the oxygen partially negative. So then when we look at this, we are going to have these two lobes, and you're going to see this more when we build these molecules on during the lab that we're going to do. Pyramidal, this is when you have one lone pair of electrons on the central atom. So you're going to have a case, and again in ammonia, where you have this central nitrogen has one lone pair on the central atom, and it's going to have these hydrogens that are going to be partially positive. That's partially negative. This is going to be considered a polar molecule, and the bonds angle between the H's is going to be 107.5 degrees. Now let's look at the shapes of nonpolar molecules. Remember, these molecules are going to be symmetrical, and there's going to be an equal sharing of electrons throughout the entire molecule. The first one is going to be a linear one that is symmetrical. So O2 is a good example of that, or CO2 is another good example of that. These molecules are symmetrical. If you were to fold them in half, you'd have the same thing on either side. A tetrahedral shape, which would be a central atom that has four things around it. And these bond angles are going to be separated by 109.5 degrees. So let's look at the similarity of the shapes and their polarity. So you have one or two bonds only, you're going to have a shape that's linear. And if it's asymmetrical, it's going to be polar. If it's symmetrical, it's going to be nonpolar. If you have two bonding pairs and two lone pairs, you're going to have a bent shape, and that molecule is going to be polar. If you have three bonding pairs and one lone pair, you're going to have a pyramidal shape, and that molecule is going to be polar. And if you have four bonded pairs and zero lone pairs, then you're going to have a tetrahedral shape, and that will be nonpolar. So practice. Let's determine the molecular polarity and shape of CCl4. So the first thing you're going to want to do is you're going to draw it. So when you draw it, this is what you're going to come up with. And then you want to look, is the thing symmetrical? And what's its shape? Well, its shape is going to allow us to see that it's non-symmetrical. It is symmetrical, excuse me. So it's going to be non-polar. And you have a central carbon bonded to 4 things around it, so it's going to be tetrahedral. What about H2S? So let's draw that. Okay, when we draw that, this is what we get. A central S bonded to 2 H's and 2 lone pairs around it. This looks very similar to water, so it's going to behave the same way. It is polar due to the 2 lone pairs of electrons on the sulfur, and it is going to be a bent shape. So let's check your understanding. Determine the molecular polarity and the shape of NF3. We're going to look at this one in class tomorrow.